Hi everyone, welcome to lesson 4.2, continuing our discussion about inequalities. Today we're going to talk about solving inequalities when we're looking for an unknown. So let's take a look at the aim. I can solve and graph inequalities using inverse operations. This is very similar to solving linear equations. Just as we can solve linear equations by using properties of expressions, the commutative, the associative, and distributive, and the equations, addition and multiplication properties, we can do the same for inequalities. But we have to make sure we know what those properties are. So let's test them. Okay, inequalities have one really weird rule that's different than equations, and we're going to explore that right here. So exercise 1. Consider the true inequality 4 is less than 8. That's true. 4 is less than 8. And let's do some experimenting with it. So A says if we add 3 to both sides of the inequality, what is the resulting inequality and is it true? Well, let's rewrite it. 4 is less than 8, and let's add 3 to both sides. 3 plus 4 is 7. 8 plus 3, 11. Is this still true? Is 7 less than 11? Yes. Okay, so adding works. We can add to both sides and it works. Instead of writing it that way, let's say adding works. Okay. If we subtract 4 from both sides of an inequality, will be the same. Alright, let's try subtracting. So 4 less than 8. Let's subtract 4 on both sides. So 4 minus 4 is 0, and 8 minus 4 is 4. Is 0 less than 4? Yes, so subtraction works. Letter C, if we multiply both sides of the inequality by 2, what's the resulting inequality? So same inequality, 4 less than 8. Let's multiply both sides by 2. 2 times 4 is 8, and 8 times 2 is 16. Is 8 less than 16? Yes. So multiplying works. And finally, let's try division. If we divide both sides by 2. So 4 less than 8. Let's divide both sides by 2. 4 divided by 2 is 2. 8 divided by 2 is 4. Is 2 still less than 4? Yes. So adding, subtracting, multiplying, and dividing all work the same way with equations of adding and subtracting, multiplying, and dividing on both sides. Okay? Based on exercise 1, you might conclude that the truth values of inequalities have the same properties as the truth values for equations. But there's one huge difference between linear inequalities and linear equations when we're solving them. So exercise 2 is going to show that. So if I look at this, 4 is less than 8 still. I'm still thinking about this inequality. And I'm going to experiment with now some negative numbers. So A says if we multiply both sides of the inequality by negative 2, what's the resulting inequality? So I'm going to do this again. 4 is less than 8. But now I'm going to multiply by negative 2 on both sides. And look what happens. I'm going to get negative 2 times 4 is negative 8, and 8 times negative 2 is negative 16. Now look what happened. Is negative 8 less than 16? No! If I draw a number line here, negative 16 is way down here, and sorry, let me redo that. Negative 16's here, negative 8 is like here. Negative 8's greater than negative 16, so no! It's not true at all. Somehow multiplying by that negative number made my inequality not true. Let's now try with division by a negative number and see what happens. I have my same inequality, 4 is less than 8, and when I divide by negative 2, 4 divided by negative 2 is negative 2, 8 divided by 2 is negative 4, and this is also not true. Negative 2 is not less than negative 2 is not less than negative 4. It's actually greater than. So here we come to this really important property. Okay? Number 1, the addition and subtraction property says if A is greater than B, it's true, then you can add C to both sides and it be the same. So this is saying that adding or subtracting is always okay. If it's positive or negative. Adding and subtracting is always okay no matter what. Number 2 property, however, is a little different, and this is one we really have to think about. The multiplication and division property says if A is greater than B, it's true if you then C times A is greater than C times B will be true if C is a positive number, and it will be true if C is a negative number. So what this is saying is that, in a much easier to understand language, okay, is that if you multiply or divide by a negative number, you must reverse the inequality. Please write this down. This is very important, okay? So if I take a look at my top problem, letter A, for example, instead of saying this -8 is less than -16, I would flip it and it would become -8 is greater than -16. Now it's true. Same thing with this one. Instead of -2 is less than -4, I would just flip it to a greater than sign. Now it works. So whenever you multiply by a negative number, you have to reverse the inequality. Okay? So let's make up one. Exercise 3 says write a true inequality and show that it becomes false. Let's make up an inequality. 10 is greater than or equal to 1. Now let's multiply or divide by a negative number. How about we multiply by -3? 10 times -3 is -30, and 3 times 1 is 3. Sorry, -3. Is -30 greater than -3? No, but we can make it true by flipping this to a less than sign. Now it's true. Okay, we want the truth, so we want the statement to be accurate. Okay, now this seems very obvious when we're just working with numbers, but you know, when we're working with letters, like we do in algebra, it's not always obvious what the inequality is showing. So we have to memorize this flipping idea. So let's take a look at some examples that use the flipping. Okay? Exercise 4. Given the linear inequality 4x minus 3 is greater than 5, let's do the following. First, let's solve the inequality by applying properties that we found earlier. So to solve this, it's very similar to solving a linear equation. Okay, so I'm going to try and get x alone, so I'm going to add 3 to both sides. 3's cancel out. 4x, instead of an equal sign, I have a greater than or equal to. 5 plus 3 is 8. I'm going to divide both sides by 4 to get my answer of x is greater than or equal to 2. Now, did I divide by a negative? No. 4 is positive, so I keep the inequality the way it is. I didn't have to divide by a negative, so I keep the inequality x is greater than 2. Okay? That's part A. I've solved it. Part B now says write 5 numbers that make the final solution true and plot them on a number line. So the answer isn't 2. It's not like an equation where the answer is 2. The answer is x is greater than or equal to 2. So some answers could be x is 2, 3, 5, 10, 20, 72, 102. Do you see where I'm going? It can be anything greater than or equal to 2. Okay, now this says write 5 numbers that make the final solution true and plot them. Now, x has to be greater than or equal to 2. So if I label these a little bit, I can see that 2 is right here. Now, there are a couple rules to graphing, and I need you to write them down. If you have a less than or equal to sign, you're going to make a closed circle on top of the number. So I'm going to go to 2, and I'm going to make a closed circle on 2. Okay? Because it's greater than, I'm going to draw an arrow to the right above my number line. Okay? And that's the graph. Boom. Done. I've graphed x is greater than or equal to 2. Now, a couple other symbols. If you have a... Oh, I'm so sorry. I'm messing this up. This is a greater than or equal to. If I have a less than or equal to, I'm going to draw my closed circle and have an arrow pointing left. If I have a greater than without the equal to part, I have an open circle and an arrow pointing to the right. And a less than, I've got an open circle and arrow pointing to the left. Okay? So a cool trick is that, you know, the arrow points in the direction of the inequality. Okay, this one here and this one right here, the letter C, it pointed to the right because we want all the numbers greater than 2. So it's covering 3, 4, 5, 6, 7, and the arrow right here, this little arrow, means that it's going to go on forever and ever. X will always be greater than 2. Okay, this right here, you need to memorize. Okay, and I have a little key written here, and on the answer key later, I have this again of how to graph these symbols on your number line. Okay? Let's do some more practice though. Let's take a look at this next inequality, in exercise 5. Given the linear inequality, x minus 2x is greater than 16, do the following. A, rewrite the left-hand expression as an equivalent expression using addition. Okay, so what they want us to do is instead of saying 8 minus 2x is greater than 16, they want me to switch the negative 2x and the positive 8 around. Okay, so see how I just moved the negative 2x and the 8 and I switched them around? This makes it easier to solve it, right? This property, you know, is called the cumulative property. We just switched our terms around. My pen is doing weird things right now. Hold on a second. Sorry. We just switched the terms. Okay? Letter B now says solve the inequality by applying properties. So I'm going to take this negative 2x plus 8 and I'm going to rewrite it over here. Negative 2x plus 8 is greater than 16. Now you don't have to do step A. This is just to try and help you see it better. Because now I can see that I want to subtract 8. Whereas before, if like you look right here, it might not be as obvious that you should subtract 8 first. It's a little bit harder to see, so we rearranged it to help us see it better. These 8's cancel out, and I'm left with negative 2x is greater than a positive 8. Now to get x by itself, I divide both sides by negative 2. And when I divide by negative, what do we have to remember? We have to flip the sign. So this becomes x is less than negative 4. I had to flip my inequality and get x is less than negative 4. If you don't flip it, you will not get it correct. It's really important to remember. When you divide or multiply by negative, you flip your sign. Okay? Letter C says pick a number that is true based on your solution to B. So here's my solution to B. I'm going to rewrite it. X is less than negative 4. Let's pick a number. What's a number less than negative 4? How about, let's pick 0. Okay, 0 is less than negative 4. So now I'm going to plug it in. I'm going to plug in 0. When I plug in 0, I get 8 minus 2 times 0 is greater than 16. Let's see if this works. Oh, I'm so sorry. I'm silly. 0 is not less than negative 4. How about let's pick negative 6. That's my bad. The 0 is actually greater than negative 4. So pick negative 6. So now I have 8 minus 2 times negative 6. What the? How did I get that to pop up? 2 times negative 6. I swear, I'm going to get myself a new tablet so this stops happening. 2 times negative 6 is greater than 16. There we go. Finally plugged in the number. So then we distribute. Negative 2 times negative 16 is a positive 12. And is 8 plus 16 greater than, sorry, is 8 plus 12 greater than 16? Yes, 20 is greater than 16. So my solution seems to work with one example. Okay? Now part D, since I've got to graph this, I'm going to remember my graphing rules from before. So I have a less than sign. So I'm going to go back here and look. A less than sign is right here. So I need an open circle and an arrow pointing to the left. So an open circle on negative 4, which is right here. See, there's negative 1, negative 2, negative 3, negative 4. And I need to make my circle open because it's a less than, and it's everything less than negative 4. Okay? Alright, we're almost done. Finally, let's take a look at a way more complicated one. We're going to do a full solution and a full graph. Okay? So, let's take a look at part A. Here's our inequality. Consider the inequality as a big whole thing that I don't want to read out loud. But it's pretty scary looking, right? No, not so much. It's just some distribution, some combining like terms. What's the first thing that I always do when I start to solve? Well, I do what part A says, where I use all the properties, and I simplify the left, and I simplify the right. So I'm going to rewrite my the whole equation to keep my work nice and neat. 8 times x minus 2 minus 3 times 2x plus 1 less than or equal to 7x plus 4 minus 3 times x plus 1. Now, if you want to right now, and you want to try and solve this on your own, I highly recommend it. See if you can do it, test your skills, and then check and see if you're correct. Okay? Alright, so let's solve. I'm going to first do all of these crazy distributions. There's 3 of them. 8 times x is 8x. 8 times negative 2 is negative 16. Negative 3 times 2x is negative 6x. Negative 3 times 1 is negative 3. So there's my left-hand side distribution. I can't do anything with that 7x and that 4, so I'm going to bring it down. Negative 3 times x is negative 3x, and negative 3 times 1 is negative 3. So that's my distribution property. Now I have to start combining like terms. Be very careful here. You don't need to start doing the sides yet. We're just working on like terms right now. So I see that 8x and negative 6x are like terms. What's 8x minus 6x? 2x. Okay? Then I've got a negative 16 and a negative 3. Negative 16 minus 3 is a negative 19. I'm going to carry down my less than or equal to sign, and I'm going to combine like terms on the right side. 7x and negative 3x are like terms, which is going to give me a 7 minus 3, which is a 4x. And then I have my numbers. I've got a 4 and a negative 3 to combine, and 4 minus 3 is a positive 1. So I've combined like terms, and I've done what A says, where I've simplified the left and right hand side. I can't simplify the left to the right anymore. Okay, so that is the answer for part A. Now part B says, solve the inequality using properties of inequality and graph the final solution set on the number line. Okay, so I'm going to rewrite it. 2x minus 19. I'm just carrying this over to here. 2x minus 19 less than or equal to 4x plus 1. Alright, now we're going to start to solve this. I'm going to use a different color. First step, I want to get x's on the left side. So I'm going to subtract 4x from both sides, because I like my x's on the left. These x's cancel out. 2x minus 4x is negative 2x. Bring down my negative 19, my less than or equal to sign, and the 1 that's left over. I'm going to add 19, just like I would in an equation. The 19's cancel out, and I'm left with negative 2x is less than or equal to 20. And then finally, I'm dividing by negative 2. But because I'm dividing by a negative, what do I have to do? I have to flip the sign. So instead of a less than sign, I have to make it a greater than sign. These cancel out, and I get x is greater than or equal to negative 10. Okay? I had to flip my sign. Okay? Really important. Okay, the last thing it says to do is graph. Whoa, that's interesting. Oh, I didn't know I could do that. The last thing it says to do is graph. I'm going to circle that for you so you can see. Graph the final solution. It's really important with redirections. On a number line, you draw by hand. I'm terrible at drawing number lines, so I'm going to actually use quite a bit of space here to make my number line look nice. Okay, so here's my number line. I have x is greater than or equal to negative 10. So what I like to do here is I kind of like to start at like a number before. You don't have to do this. It doesn't really matter how you make your number line, but do you notice that I'm always going up by the same amount? Well, if I can count properly, this would work. I'm going up by the same amount every time, right? I don't want to just start at negative 11 and go to like the number 1. Okay, so here's my number line. I started at negative 11. You could have started anywhere you wanted. As long as the negative 10 is on there, you're fine. I'm going to go back to my little guide that I wrote for you guys, and look, which one do I need? Well, the problem has a greater than or equal to sign, so which one do I need here? I need this one, where it's a closed circle going to the right. So I'm going to make a closed circle here and draw my arrow to the right. Okay. one last thing before we finish up. This problem is all the complete, but I want to give you guys a reason for why we have this closed circle, right? Because we're basically saying that we're including the number here, right? This greater than or equal to means that x could be -10. So we close the circle because it's including it. We have an open circle for less than or greater than because it does not include. If I say x is greater than, let me draw that a little better. If I say that x is greater than 2, could x be 2? No, x can't be 2, right? The 2 is not included. So that's why we have this open circle, closed circle situation, right? So we know what our inequality is stating. Okay? Good luck on your fluency. Lessons 4.1 and 4.2 have combined mastery, so 4.1 and 4.2 don't have separate ones. Okay? Good luck on your fluency, and I will see you in class.